So
yes.
the day before we submit modified.
Yeah.
And are you just in morning, like next day morning?
Didn't I reply to you?
I'm sorry?
If you didn't get an email back from me, I said, yeah, that's fine.
I didn't get it.
Well, probably haven't. I got interrupted, so
yeah.
I wrote you.
Yeah, sure. So I didn't get a reply from you, so I just submit online as well. Because I emailed you and both. I did both the email and the submission online. So because I didn't get email, so I'm not quite sure that.
Yeah, no worries. No.
Yeah. I'm sorry for that, but just one.
I didn't realize.
I saw the code book is available on Bako.
Yeah.
But it wasn't because I upgraded the software online. So the latest version does not have the code book application. So probably next.
The latest one.
The latest one is 11.4.
Yeah, right.
Yeah, there's only like the word cloud, and the rest is available. Yeah.
Okay.
The other was just. Yeah, I'm sorry for the.
Oh no, I didn't realise that was an issue. So that's fine.
Thank you.
No problem. Okay, good morning everyone, and welcome back after 1 week of a break, or we call it a break. So today we're going to revise a little bit make sure sort of take stock of where we've come from over this semester. And we're going to have a look at the end of the last lecture that I left on an example, and so we'll come back to that. And then we'll also have a quick look at cost-benefit analysis and contingent valuation method. Can I have a quick show of hands of people who've come across any of those tools before? So cost-benefit analysis, you heard of those sort of things? You might have heard of that jargon before. Okay. Whether you've heard of it or not, as we go through this, I want you to use this as a great example to operationalise the material that we covered earlier in semester, okay? So that's why I'll remind you of what we went through in the first weeks of semester, and as we go through, I want you to be trying to apply some of those principles and ask the sort of questions that a researcher would be asking. We want to move beyond simple memorisation and think about how you could apply these sorts of things for problem solving. Okay. So that's what we're going to do today. Have a quick look at the semester so far. Look at a simple example of multiple criteria analysis. We'll talk a little bit about the wisdom of crowds, which is also reflecting back on some material from the first week. Look at the basic steps and components of benefit cost analysis or cost benefit analysis. You see it around either way. And the one that's not on there should be CVM. So all of these are different ways of making decisions, of framing decisions, and of course to make these tools work, we need applied research that's feeding data into these tools as we go along. Okay, so in terms of where we've come from, I don't have my pointer today. Yep. Okay, so in terms of where we've come from, I just want to jog your memory. You've done most of the assessment for this course now, but of course there's an exam coming up. And so the best way to prepare is to start to embed that knowledge now. And even though the exam might be the main thing you're interested in, once you get out into the workforce, nobody's going to ask you what you got on the exam for this course, but they are going to want to see if you can use these sorts of approaches in your work and to solve problems. So that's my sort of not so hidden agenda here. So first of all, week one was a basic sort of introduction, talking about the difference between science and common knowledge, the way scientific method works. Week two, we talked about research design and measurement, different types of data and variables. Remember, we talked about the challenge of operationalising concepts into a form that we can then gather data on. I would say that that is a fantastic skill to be building up as you look at issues happening around you that are important to you or that you're interested in. It's a bit nerdy, but have a think about how could you actually measure that particular thing, because often the things that are most important to us, most important to society, are not so simple to measure. They might be values, they might be complex concepts. So we talked about how to operationalise. Week three, we started talking a bit more about data analysis, descriptive statistics. Remember, we covered some of the basics around variability of a sample and the central tendency of a sample and what do those sort of things mean. We talked a bit about the normal distribution and what having a normal distribution allows us to do in terms of statistics and the powerful, the more powerful methods that we can use in that situation. We also, moving on to week four, remember we talked a bit more about hypothesis testing, type 1 and type 2 errors. So I gave you a way to remember that. So have a look back at that if you can't remember the difference between type 1 and type 2 areas. And the way to remember it is that the tale of the boy who cried wolf. Have a look at that slide. So we started to also look at different types of testing as well. So inferential testing. So we were looking at t-tests, and then the week later we looked at ANOVA, and we looked at a number of other tests where we could try and understand what's going on with our samples, and then what we can infer to the general population using inferential statistics. You had 4 classes on, you had a couple of classes on qualitative research, and so Christine Slade took those, and that was the basis for the final prac that I'm sure you're very happy to have submitted now. So remember those key differences between qualitative and quantitative research, and that's one of the tensions when it comes to applying applied research and these decision-making tools that we're about to talk about. How do we actually measure some of these qualitative issues in a way that decision makers can decide how to distribute public funds, and all sorts of, public funds more and more are very limited, and so the way we feed this data into our work has a huge impact on how sustainable our cities and our societies are going to be in the future. Okay, so I want you to keep those sort of things in mind. Remember last week, the last lecture, we sort of started to switch into the more applied research mode. We talked about planning goals, objectives, performance criteria, etc. And that's really the frame that sits around the work that we do. In any organisation that you might work in, you need to understand that. I think I mentioned some of the examples that I saw of environmental planners that found goals that had been set by their organisation or their local government, and they were able to design projects that were going to improve the environmental management of the city, and they could clearly show how their project would contribute towards achieving this goal that the organisation had set. So that's something to keep in mind as well. You might be, just following orders for the first few jobs you have after you leave this place. But if you, at some stage, want to be in a more creative situation, applying for tenders, applying for grants, or pitching project proposals, then you need to think about those sort of things. What sort of research or projects can you design that will contribute towards the broader goals and objectives within your organisation? Okay, so as we go through these tools, I'd like you to see if you can connect some of this material that we covered earlier in semester with what we're talking about. Try and imagine yourself in the shoes of the researcher here. What sort of data would you need? What would be some of the challenges around collecting that data? How would you know if it's a robust sort of sample? How would you operationalise some of these concepts? I would say operationalisation is an incredibly important vocational skill. It's the best researchers and practitioners that I've seen come up with very often quite efficient, but very, very strong links between what they're measuring and the concept, and then the way that they've operationalised it. For those of you who go on to do further research, thesis, or PhD, masters or PhD, that's the same sort of robust argument that you need. What's your problem? What's the concept you're looking at? How are you going to operationalise that? How are you going to collect data on that? And then how are you going to analyse that? Okay. So just coming into the last lecture before the break, I sometimes find that People have a bit of a memory blank after even a 1 week break. Remember, we talked about different types of decision criteria, and then we fed that into this idea of multi-criteria analysis. And so we had this very generalized decision matrix where you've got criteria there on the left that you're measuring against, and then you've got 4 different projects, and you're weighing it up. Which one is going to be the best for investing resources into. And then we talked about that there's a number of approaches to doing this and to calculating, to bringing those bottom lines together, those different decisions. So the simplest one, and I'll get you to apply this one in just a minute, is the dominance approach. So basically, which one fulfills the most number of these categories? You weight them equally in this situation, and so in this situation, option D would be the best. We talked about a criteria ranking approach, where ahead of time you would rank which ones are most important. And so if, as is usual, economic might be the most important, then as soon as you get to that, if there's no other projects there that have economic, as in this situation, you can just stop there. But can anyone tell me what is the use of those other bottom lines in that circumstance? So this is the reality that you might be working with, is that in the end, governments and businesses, organisations will make decisions based on economics. Sometimes, especially at the moment, in terms of global economic cycles, economics is really tight, and so the ability to choose a different way forward that's not the most economically feasible is really difficult. So what could you then do with this data that you've gathered around biological, social, administrative and equity? Is it worth anything, or do you just chuck it in the bin? So on a lot of big projects, you would be also trying to mitigate and offset your effects. And so that could be part of how you would then use that data. Even though it may not be used for selecting the actual project that you move forward on, you could then use it in your monitoring and evaluation. You could also use it to improve your database of what your projections were in terms of the value or the impact of those projects. There's always something that you can put that data for, so you would never throw it out. And I guess one of the challenges that we're dealing with when it comes to planning and environmental management is the complex systems that we're working with make it difficult for us to have, well, we can never have comprehensive knowledge about the real world setting. So the more data that we can gather, the better. So in this situation, you might use, if project A was selected, you might use B, C and D as part of your argument for having a very good monitoring and evaluation program that you would then be trying to minimise the impacts of project A and perhaps draw on some of the advantages of project D if possible in terms of biological and social. Then we also talked about, I guess, building on that, you might have a weighted criteria approach where you say, well, actually all these criteria are important, but some are more important than others. And so we talked about having the ability to weight those. Finally, we talked about a screening approach where we might say that there's a minimum acceptable value that we're going to have. Perhaps this might be set even by the legislative framework. If there's particular biological resource in the area that this project is happening, there might be a particular bottom line that you have to meet. And if a project can't, is going to cause irreversible damage to that resource, then you can just screen it out and you don't have to go any further. Okay, so of course, applying this in practice is going to be a lot more complex. We haven't really talked about how you would value those different bottom lines and bring them together. beyond those simple tools, but I want to apply it now to this simple case study. So in this situation, which is a real situation that happened, there's a national park here, Bako National Park, and they want to extend their trail system through the park. Those of you who are interested in protected areas will know that it's always a balance between conservation and human use. But they don't have enough money to buy all 4 parcels at once. They're going to have to buy 1 per year. And if you know anything about governments and politics, you probably have no 100% certain chance to know whether you'll actually get 4 years of funding to buy all 4. Let's just assume that you probably will, but you're going to have to select the best one at each point, okay? So you've been assigned the role of lead analyst to determine which of the 4 alternatives, which of the 4 parcels of land you're going to select for this first year. So here are the 5 decision criteria. It's a little bit blurry, but you can probably see the top one is physical. And you can see there that you can have sub-criteria under a criterion in MCA. So you've got there kilometres of additional trail. So obviously more kilometres is better than less. Total hectares, more is better. Trail diversity. So it could be, not just all easy, so difficult, easy, sealed, unsealed, etc. And so we're going to say that in terms of the recreational value of this purchase, more trail diversity is better. So as we go through, you might think about, I'm going to get you to apply the dominance approach and have a go at working out which of these 4 parcels of land you would purchase. Economic, we've just got there the net benefits. So we can probably assume there was a cost-benefit analysis done there, and so they said, well, what are all the benefits over time? Well, actually, it doesn't say anything about costs, but we can assume that. And so they've valued, perhaps that could be from the value of tourism, what might be the net benefits there. So once you come into dollars, everyone relaxes and goes, all right, a standardised unit, I know what's going on here. Now here's interesting, political feasibility, because obviously if you're going to spend 3 to 6 months arguing over, getting the decision through to purchase this land, you have to weigh up what that might cost as well. So there's a feasibility index here. We don't have information on the inner workings of that, but the higher that score is, the more feasible the purchase is in terms of political opposition or political support. Then down under here, we've got social cultural. And so you might say, well, how can we measure social and cultural criteria here? And can you pick up what they've done there? Can you read those? Environmental NGO, Regional Tourism Commission, Indigenous groups. What does that look like to you? Getting your brain thinking. How have they approached this? They've gone, we have to measure the social and cultural value of these 4 different parcels of land. You can see there that there's some numbers there. They're all in the plus. And we've got those different categories: NGO, Tourism Commission, Indigenous groups. How do you think they've approached this to frame it up? How have they operationalised social and cultural criteria? So I would say, well, first of all, when you look at those groups, they've done some sort of stakeholder analysis and they've identified who are the main stakeholders here. And then here, can you remember seeing any little numbers like that before? How would you establish those numbers? That to me, and it is, looks like a Likert scale, okay? So they've done a stakeholder analysis, gotten the main stakeholders, then they've surveyed them and asked them a question, probably getting them to rate between 1 and 5 on how important the purchase or how significant the purchase of these particular blocks are. And so that's how they've come up with that value there. So this is part of what I was talking about, of taking the material from the first part of semester and applying it into decision-making tools. So even though we're talking about multiple criteria analysis here, each one of these criteria kind of has its own little research project behind it to collect and analyse the data. Underneath there, that's pretty straightforward. Administrative, the number of personnel hours required, and so hours is a nice standardised one, and you could probably convert that to dollars pretty easily as well in terms of the average wage of the administrative staff. So have a quick chat to the people around you. I'll give you a couple of minutes and see if you can decide which alternative you would pick, which parcel of land, if I put you in charge of this bucket of money, which, or the analyst anyway, which one would you recommend be purchased first? If you're really ahead of the game, you might also think about how you would present your report. You can probably guess that the economics will be something the decision makers really want to look at. So if you're wanting, in the dominance approach, it's an equal treatment of these different criteria. If you think the decision makers are going to zero in on economics, you might have to, in your report, put forward very strongly and clearly some of these other criteria. Okay, let's go through it. Before I do, I just want to again connect this back to the material from the start of semester. So you could go through each of those and think about what's the concept here and how's it being operationalised. You can see that with the physical criteria, they've used a number of ways of operationalising that concept, 3 different ways. This often happens with more complex concepts that you're trying to operationalise, and it helps to give a more, I guess, a more comprehensive approach to that. I want you to think about how robust are these approaches, and as I was saying before, think strategically. How would you present this evidence? How would you collect it? How would you defend it as good research? What sort of sample size would you need for those for the survey that you're going to do there? What sort of robustness would you need for that feasibility index? Think about all the parts of this report where when you're presenting it, somebody that doesn't support your proposal is going to query, how did you go about all of this? You have to be ready to do that. And they might not even be in opposition, they might find it really interesting, they might just want to know more. And if you can show that you know what you're about and you're presenting this in a very robust way, that'll be all the better for you and your work. Okay, so let's go through. When we look at physical there, kilometres of additional trail, which one's better there? A and C, we've got a tie there. And so we're going to have to look at some of the ones below there. So total hectares, more hectares equals better. So which one's better there? C. And then A is better for trail diversity on that trail diversity score. And so using the dominance approach, where we just give a score of 1 for each of those, we would say that A and C each get 1 point there. Economics, well, that one's pretty straightforward. Hopefully you all know how dollars work. So we've got the best one there is C. So at the moment, C is winning in terms of the dominance approach. Each approach is equal. Then as we go down, we then have a tie there for the political feasibility. And then how would you work out social cultural using a simple dominance approach? So there'd actually be a few different ways. You could add them up and average them. That would probably be the smartest thing to do. Depends on your sample a little bit. So if you've got comparable samples, then you could just average them. If you don't have comparable samples, so perhaps you've got a lot more NGOs, which is actually likely to be the case, and only one tourism commission, then you'd probably give a score, the dominance approach, as we did in the top one. You give 1 point for each of those categories to keep them weighted. Remember, there's going to be a lot of politics around this. If the Tourism Commission thinks that you've shortchanged them by averaging theirs in amongst these other groups, you're going to have a lot of extra political opposition. Okay, and administrative hours down there. And so using the simple dominance approach, if you went through there, you could say that option C would be the parcel of land that you would buy first. Is that the one that you came up with, or did you use different types of reasoning? Anyone else come up with a different one that they wanted to share? No? Well, just like in Prac 5, where you've done a code book and it talks about how you've categorised things. Similarly, with any report, any research that you're reporting on, you would want to also detail, probably in an appendix or the methods section, exactly how you arrived at this score, exactly how you measured it, what some of the, perhaps what some of the diversity is, some of the details that you can't quite see in underneath this. So, for example, again, tying it back into material from earlier in semester, you might say, well, that's the mean, but is the mean the one that we should be using here? And what else are we missing around that? And so straight away you might be saying, well, perhaps if it's a very diverse group, we'd also want to give the standard deviation in some sort of appendix or in the main report to give people more detail on that. Okay, let's move along. And again, I got you to start to warm up your vocal cords before, but let's say you'll get to talk to each other a little bit more here. And I touched on this very quickly towards the end of the lecture last time. And this is this idea that is critical when it comes to public decision making in almost any context. Even in non-democratic systems, there's usually a range of people that will be involved in decision making, and it takes on a similar dynamic to this. And the main argument is, when we involve lots of stakeholders or the public in applied research and making decisions, so for example, in the multiple criteria analysis, we could have a range of ways of drawing data from the public. Is it going to be like the French Revolution there, where we get feedback from the public that is reactionary, that is out of perhaps groupthink that is carried along by the crowd? Or is it more like the hive mind of a bee, where we can tap into the wisdom of a crowd and get this huge diversity of perspectives and a very comprehensive view of the problem? And so I want you to just briefly reflect on this can a wise crowd make the tough decisions? So where you've got a very controversial decision, can you tap into the wisdom of crowds, those different perspectives, and make a good decision that way as an applied researcher? And why not? I'll be interested in your perspectives on that. So I'll give you, again, 2 or 3 minutes to discuss that, and then we'll get some feedback from everybody. There's no wrong answers here. I'm just asking for your opinion. All of you are drawing on different backgrounds. Perhaps think about a setting that you're familiar with and whether you think a controversial decision in a particular point of the globe is able to draw on the wise crowd, or whether it's going to be taken over by the rule of the mob. Okay. Do you think, and this is not just a philosophical question, when you're in the workforce and you need to make a decision that impacts the public, there will be pressure on both sides in terms of your work. On one side, you might have people saying, we've got to make this decision fast. We've got a lot of expertise within our organisation. We're competing against other organisations. It's going to take too long, or it's going to get controversial or whatever. So just make it without the public. Then there'll be some people that will be saying, no, We've really got to make this decision with other people. It impacts them. It's going to be faster in the long run. We may not have all the information. There'll be all those reasons. So you'll be working within a context where this is not just about philosophy. It's about practical ways forward for your work and different opinions that people will have about how you should do your work, which is always lots of fun when people have opinions about how you should do your job. So, should we start with do you feel positive or negative at 20 to 9 in the morning? Let's start with the why not, and we'll see which one you can get a longer list on. Well, who sort of thought there's problems with involving the public, and we're likely to get this sort of mob mentality? Did anyone talk about that and the likelihood of that happening? There's definitely fears at the moment in terms of some of the discussions in Australia around the way our politicians might be affected by the public and how wise that crowd is. Does anyone want to share some of the things that you talked about there? Actually, let's just go in general. Why or why not? What sort of things did you talk about? Yep. So if we can get the wisdom of the crowd there, then we can get a better decision. And you're saying that in the past we've tried not using the public, and especially in a lot of areas of environmental management, sustainability, that means that we've only heard from a certain set of perspectives. Any other views there? So that's particularly the case in where you've got a large diversity of stakeholders. What about where something's really controversial? Do you think it's possible there? What sort of things would you need in place to involve the public in a controversial decision where it's polarised? Come on, think like researchers. You might have to solve problems like this. Definitely those of you who are in planning, when you go into the workforce and you get sent out as the student or even environmental managers to talk to the public, if you don't understand some of these dynamics, you're likely to get into, you'll understand it soon enough, within about the first 10 minutes, let's say. So what sort of things would you need in place if you were going to involve the public?
Like a participatory process, something that makes them feel included in the discussion.
Okay, yeah, so participatory, getting them all together and dialoguing, that sort of thing. So how do you stop it descending into some sort of manic argument, which public meetings often can do, it's controversial. How do you not end up with the mob? You turn up to a public meeting or something, you want to involve the public, you want to get their view on something, and you find out, you get there, and everybody's opposed to the idea, they haven't heard the information yet, but they're worried, they don't trust your organisation, something that happened 15 years ago that some of them still remember. How would you manage that? No idea? Well, there's a reading for you to do there. I'll show you the reading. That is the shortest list for this exercise I've ever had. There was some stuff, I just didn't write it down. So, basically, and I think I touched on this last time, there's this author who's written some great stuff, and I will put those readings up. I think somebody has posted something on Facebook about the readings from here and into the rest of the semester, and I'll fix that up over the next week. So this author, he talked about all the ways that crowd intelligence can fail. I guess just as we used to have an assumption that the experts can make the decision, we have also gone through a bit of a stage of naivety of, well, let's just involve everybody, and then coming up against some of these failures of crowd intelligence. So you can see there, a lot of it's pretty straightforward if you think about it, that you can end up getting heated emotions involved. You can end up having groupthink, and so perhaps everyone at this meeting, well, we're not if we were making a decision about the whole university, perhaps this group here is not representative of the whole university. But then there's a whole range of other things that come into play in terms of the difficulties there. I would say that, like, I was very lucky to do some research in a city in the States where they're kind of forced to involve the public in decision making, which means that everything's quite slow. But also what it's meant is over the last, these planning laws came in 1972, and since then they realised, well, if we have to involve the public, then we need to do things to try and avoid this failure of crowd intelligence. For example, one of the things that happened in this place, this is at the state level, not just the city level, is that there's a group of people in the States, they're called property rights activists, and they wanted to get rid of environmental planning, basically. And so they put forward a motion, which then passed in this ballot, that said that any environmental laws that were put in place had to compensate the landowner for the development rights that they may have lost. And it was basically going to stop any future environmental planning from happening because no government could afford to compensate them. And so part of what they did, so that passed and everything ground to a halt. And then over the next 3 or 4 years, what do you think they did to try and increase the intelligence of the crowd? They did a lot of education, they did a lot of empowerment, they broke down some of these issues. They tried to work at where is the emotionality of this situation? Why did a small group manage to sway the whole state? How do we balance that situation? How do we make sure people have as much information as possible so they understand why we're making these particular environmental and planning decisions? And so they sort of built it up, and it fits in nicely with this paper that I can't really say state, Surowieki put together, where sort of identifying criteria that makes it more likely that you can tap into the wisdom of a crowd. And so putting these sorts of things in place can really help to do that. We don't have time in this course to go into it, but I'll put a link, and some of you who are in other courses with me have seen it already. There's a website on public participation GIS, because that's a very interesting tool for trying to make information available to people and involve people in decision making, and to collect data from them that is more likely to be wise than simply asking them a survey. So there's a lot of research that shows that once we were able to put a spatial analysis into these sort of decisions, that the public was better able to give us good data on what they wanted. Okay. Now, what I'm going to do now is we'll go through the cost-benefit analysis material, then we'll have a short break and we'll do contingent valuation. So cost-benefit analysis, or benefit-cost analysis, I think I've used both terms in this. I think it's, we probably get this one from the British, and the US go for the glass half full rather than half empty, and they do benefit cost. Okay, there's a few basic steps, and think about what these steps remind you of. So you have to define the problem and the analysis environment. We'll talk about what some of these components are for those of you who aren't familiar with it. So we need to think about, well, what are the different alternative projects that we're looking at? And we need to compare that against a baseline, a do-nothing scenario usually. We need to think about what are the constraints. Do we have budget constraints or other political constraints, etc.? And we need to think about this thing called a discount rate, which I'll explain. Then you need to design the analysis. So first of all, which decision criteria are you going to use? And there's these three that I'll go through quickly: net present value, benefit cost ratio, and internal rate of return. You obviously need to identify all the different costs and benefits, and then you need to think about which variables might swing it. And I'll explain what sensitivity analysis is in a minute. Obviously, then you need a plan for how you're going to collect that data. And although this sounds nice and straightforward, as you probably know now, similar to the qualitative exercise, this is an iterative process. So you might come up with a data collection plan and your colleagues say, that's great, but it's too expensive. Find a simpler, more efficient way to do it. Obviously, then you go out and collect the data, and then you have to perform the BCA that you've, see, I've got it around two different ways on the same slide. You've got to perform the analysis that you've outlined in step 2. So you need to do that quantification. It's all expressed in dollar terms. Then you compute what a decision comes up with based on that criterion, and then check out if there's particular variables that would affect the result significantly. Finally, you have to present the results. Well, let's go through what some of those different aspects are there. So discount rate, I think a couple of people twitched when I asked before if you've heard of cost-benefit analysis. Probably more of you have heard of discount rate before. Basically what it is it's about trying to measure the time value of money. So if you put $10 into a savings account, at the moment you're probably getting just a couple of 2% interest or something, and you left it there for a year, you would have $1.02. Don't spend it all at once. And so the discount rate is like moving in reverse. So if the value of our dollar is worth $1.02 in the future, in 1 year, then the value of that $1.02 in 1 year's time brought back into today's figures is $1. Okay? I'll show an example. But the other thing that discount rates do is they try to measure the risk or the uncertainty of future cash flows. So if a particular project or venture is risky or very uncertain in terms of when or how much cash might come back, then you would have a higher discount rate. So similarly to a higher interest rate, it would mean that instead of $1.02 equaling $1, if we had 15% discount rate, then our $1.15 in the future would come back to $1 in today's money. It uses this formula, and so you basically use the amount, and then 1 plus the I is the discount rate, and N is the number of years. And we'll go through an example. So just say we expect to be paid $1,000 from a particular, if we pick this particular project in 1 year, and there's a discount rate of 10%. To apply the formula there, the amount, $1,000, and then we divide it by 1.1 to the power of 1, and the power of is 1 year, and we come up with $909.09. If we were to say we would do it in 2 years, then that would say to the power of 2 instead of to the power of 1 at the end of the brackets there, and you'd come out with $800 and something. So you can see that the amount of time and the discount rate that is set has a huge impact on the value when you bring it into today's money. Now, one of the reasons that you would do this is in a multi-year project where you're getting cash flows back at each year and there are costs at each year, you need a way of standardising that And so that's why we bring it into net present value in order to understand those costs and benefits that are happening across a number of years. So I mentioned that you would use a particular decision criteria. So one, which I've just basically explained, is net present value. So working out the discount rate on the costs and the benefits at each year, and then bringing them all back into today's values, and then adding them all up will give you your net present value. Another way that it can be done, particularly when budgets are more constrained, is a benefit cost ratio. And so this one is the benefits, basically the total benefits in present values divided by the total costs in present values. And we'll go through a simple example of cost-benefit analysis in just a sec. And then the internal rate of return is really a measure of profitability. And so what you actually do, it's almost like doing it in reverse. So you say, well, what is the discount rate that we would need to make the net present value equal to 0? Okay. Often in government projects, they look at the internal rate of return. So here, if we have an example of a 5-year project that's returning costs and benefits at different times over those 5 years, you can see it's quite simple. In project A, all of the investment is up front, and then we have a return. In project alternative B, you can see that the costs are spread over 2 years and we don't start to get any benefits until year 3. And then in alternative 3, we have them coming most of the way through, and there's costs. I guess that's more realistic for a lot of management projects where you'll have ongoing benefits and costs as you go along. This, the top one might be, or the top two might be sort of infrastructure or large development projects where all the costs come in up front. Okay, so if we were going to look at those 3 different values, the net present value, we would add up the benefits. So you can see there in A, where's my little pointer gone? You can see here in A where we're getting 1,500 benefit in year 2, 3, 4, 5, but then we've applied a 4% discount rate here, and you can see as we move into the future, that figure in today's money starts to drop the further out into the future we go. Now, those of you who are familiar with cost-benefit analysis, does anyone want to say anything about discount rates and what that might mean if the benefits start to reduce as you go out into the future? Think about sustainability, think about management and planning. Yep. Yep. Okay, yeah, so if you're bringing it back, yeah, so you've got something that's continuing on, hopefully, indefinitely, if it's managed sustainably. How do you deal with that? Often cost-benefit analysis is done, or for projects, it's done for a 20-year period, and part of that is because once you get beyond that, things start to become, the benefits start to become 0 using this tool, if you apply any sort of discount rate. Similarly, for perhaps rehabilitation of a river or something like that, the benefits might take a while before they start flowing. And so when you bring it back into net present value, today's money, the benefits may be much lower than what people would argue they should be. Now, people with an economics background might argue the other way, but in terms of how these sort of things apply to sustainability and environmental problems, that's one of the issues. is that the benefits might take a while to accrue. Similarly, with any sort of complex social or ecological system, the costs take a while to accrue as well. Sometimes, for example, with conservation, we don't see the full extinction of species from clearing land until 10, 20 years later. And that's part of what Australia is going through now. And so how do we know what the full costs are when we're dealing with some sort of change to a complex social and ecological system? Okay. Let's say we're going to stick with this regardless of the critique of cost-benefit analysis. We're going to stick with this, and in terms of calculating net present value, you then take these numbers that are in figures and you add them all up, and that's the net benefits for alternative 1, that total there. Likewise, you can do the same here for costs and so on. And so you can then go down and look at the, you then subtract the costs from the benefits, and you come up with this net present value there. So you can see there that in terms of net present value, alternative 3 comes out the highest. So in some calculations, you would say we're going with anything with the highest net present value, that's what we're going for. In other projects that might have ecosystem services or other things involved that may not discount appropriately, you might want to put a strong argument for a different approach or for modifying this approach. Okay, so then if we're doing the cost-benefit analysis, benefit-cost ratio, we would divide the benefits by the total costs, and we come up with these numbers in this column here. So anything that is less than 1, you can scratch it out straight away. You can see there that the costs for option A, alternative 1, sorry, are higher than the benefits. So why would we do it? Okay. This is one of the places where cost-benefit analysis might be useful. If you've got a very politically popular move that politicians are pushing for, you might be able to collect good data to show that over the lifespan of that project, it's actually not worth the investment of public funding. So, for example, we need to do, for a lot of sustainability choices, we need to do that sort of thing where perhaps the immediate decision, perhaps the rule of the mob, is saying we need to build more massive houses and big suburbs on the outskirts of the city, but over time we might be able to show that the efficiency of the city, the cost of public transport, etc., are going to go way out of control, and it's not going to give us the benefit that we think it will. So that's the benefit-cost ratio. And you can see there that, again, alternative 3 comes out best there. So the internal rate of return, remember we're going to set this percentage. So we're going to set, it's like setting the discount rate so that the net present value, which is this, comes back to 0. Okay? And that's sort of a measure of profitability. And you can see here that it's only 4%. For option A, whereas it's 7% for option B, alternative 2, sorry. Okay, you don't need to know much more than that for this course. Obviously, if you were going into the details of this, there'd be a lot more to look at. Remember, you're comparing it always with a baseline, a do-nothing scenario. So it's not just what are all the benefits and what are all the costs. You need to compare it against what would be happening if you didn't invest anything. You also need to think about disbenefits as well. So, for example, if we're building a freeway and there are particular benefits and costs, and the benefits might come in around travel time and economy, etc., there could be some disbenefits, such as the impact of noise on the surrounding community. If it's a really polluting sort of project, you could have an increase in deaths related to that. And so you would have to factor all of those things in as well. So it becomes quite complicated in trying to itemise what all the benefits and the costs are. It sounds like it's objective because it gives us a value in dollars, but I want you to learn to take the lid off. They talk about a black box. These tools can become a black box where you just look at you put some figures in and the result comes out. As good researchers, you need to be able to open the box and look at how that machine, this tool, works on the inside. You need to ask yourself things like, have we got all the benefits here? Have we got all the costs? How have we measured them? Who defined what the benefits and the costs are? Are there other stakeholders that think we have benefits and costs that are missing? Is the discount rate appropriate? Why? All of those sort of questions will help you to be a better analyst and a better researcher. So you need to know how to operate the tool, but you also need to be able to know how to have a look inside the machine and see if it's actually appropriate or giving you what you need. You can bet that, so most government cost-benefit analysis, they will have given the analyst the terms of reference. They would have said, here are the benefits and the costs that we want you to measure. And so that's something to consider as well, who gets to define that. Okay, of course, and I've touched on this a little bit, there's a difference between if you're working for an organisation that's a private organisation or if you're working on a public project, in terms of what you decide is external to the project in terms of costs and benefits. For a good sustainability analysis, the difference won't be too much, but governments should have a broader responsibility. And so they might look at further far-ranging costs and benefits. In the notes for this, I'll put a bit more detail on the critique of cost-benefit analysis. We've touched on some of it in terms of delayed benefits and costs in complex systems. There's also other things around how do you put some of these costs and benefits into dollar figures. So, for example, if we're building this coal-fired power station and we're choosing between that and a nuclear power plant, and one of the things that comes up, so one of the things that's going to come up is risk and uncertainty. How do we value that, and how do we therefore choose an appropriate discount rate? How do we decide what the risks are of death, of pollution from the coal-fired power station? Do we include things like climate change in terms of the impact on climate change? So how tight or broad do we set the boundary around this assessment? How much is a life worth? How much is your life worth? How would I put a dollar figure on that? Economists do it. Do you know how they do it? They look at your income, your likely income over your lifespan. Look at the average lifespan. That'd be pretty interesting if you're students, like how much is your life worth? Of course they would say, well, once you get a job, and certain percentage of people will get a job, and certain percentage of people will earn, the average for this profession will be this much. But you can see how these uncertainties build and build and build in terms of how you value those. So again, if you're reporting, best practice would be to make your assumptions transparent, to put them at least in an internal report, at least in a report for yourself, in case you have to defend the approach that you've taken. Okay, we're just going to finish now on sensitivity analysis, and we've kind of touched on some of that there. So there are particular variables in your cost-benefit analysis that might swing the assessment between, say, before we had alternative A, B, and C, or 1, 2, and 3. And so the main one that we look at is discount rates. So if we slightly change the discount rate, how might that shift the valuation? So if you've got a project that has costs benefits further into the future, a lower discount rate is going to bring more of those benefits back into the net present value. A higher discount rate is going to lower them as you bring them back over time. There are all sorts of assumptions that get made around wage costs. Perhaps wages are going up. We're going to set a particular cost for wages on this project, and then there's a rapid rise in wage costs. Perhaps there's some sort of deregulation of the market and the bottom drops out of the wages, hopefully not. There's a range of time values. So for instance, investment in equipment that you think is only going to last 5 years before you have to buy another one, perhaps if you maintain that very carefully, you can make it last 7, 8, 9 years. So again, you might have variables that blow out. Alternatively, you might have a poorly trained workforce and they blow up the equipment in 2 or 3 years. And so if you did the sensitivity analysis there, you would be able to, again, this is how it would feed into some management and planning, monitoring and evaluation. You would then, in that situation, put a very good, well, I would put a very good employee training program in place to try and lower the risk associated with that sensitivity. There's a range of other things as well. We've talked about the environmental impacts. Other things will be, they'll often calculate if we're investing in the community, how might that contribute benefits to the broader local economy or even regional or national economy. That's very easy to get out of whack. And we've already talked about value of life and the risks that might be associated with that. It's very easy to get those wrong as well. So now that I've really knocked it down, we're going to stop for a break. That being said, cost-benefit analysis is still the main tool that's used. You can see that there's a range of ways as a good researcher for you to make it fairly robust, transparent, and there's a whole range of ways to do the research to collect the data for that. We're going to stop for a short break now, and we're going to talk about contingent valuation method. For those of you, I want to encourage you, if you've got a phone, to text a number. If you haven't used this poll before, you need to text Paul Schmidt 066 to this phone number here, and then you'll be able to answer this question. Send a second text on how much would you be willing to pay to see an orangutan in Sarawak in the jungle, free in the jungle next year, okay? How much would you be willing to pay for that experience? Okay, we'll have a look. We'll break for about 5 minutes. Please text into that and we'll see what your answers are. We'll use that as the basis for the last part of this lecture. So it is 12 past by my clock here. So at about 17 past, we'll start back again. So text Paul Schmidt 066 to that number once, and then text the answer to your answer to that question. us to work out what the rate of return is. So it's basically a measure of what percent of the use that to say what's the likely return is. So it's like working with factors. I'll put a resource up on there. There's a lot. Typically, it depends on the actual versus the service. So this has been one of the arguments. So the classic one of what we do is that instead of comparing the ecosystem service itself, you're comparing the way you're valuing it is to say how would we deal with it. Yeah, and so you get to say that that's the value of the ecosystem service. So you value it according to the replacement project of you remove that. So for the macros, that's fairly straightforward because you can imagine clearing the macros in one go. And if we talk about things like water quality, it becomes a lot more complicated because it might be something that requires slow over time. So that yeah. Yeah, it's complex because you can't just have one. That's why macros become sort of the poster child because you point to one resource and say that was this. Whereas if you're trying to say what so I think what they usually do is try and come up with some sort of proxy for water quality. So what they make is water quality. What's your thoughts? Oh, I was going to ask if you got in touch with me. Congratulations. Yeah. But this is really skill. I might be able to put you in touch with someone who is involved at the end. And he did an evaluation of ecosystem services. And he used to work just catch up with me and I'll keep getting this back. Okay. Let's, I only saw the first couple of answers. All right. I don't know where they all went. So these are some of the values that you and your colleagues have sent in of how much you would pay. Someone's been very, very diligent and given us which dollars, Australian dollars, 30, 100, 90, 50. I didn't really ask where you were going from. Maybe the $50 is if you're already in Sarawak. I don't know. If you're trying to get from Brisbane to Sarawak, I liked this one. This person's it's 0, and people will often say 0 in these sort of surveys. So actually, there's a better spot. Oh no, not William. And there was someone else that had a different one. Not interested. That's good. 0. Some of you might have looked ahead on handouts. Okay, yeah, this one. Actually, there's a better spot to see these orangutans, so I'm not going to pay anything to go there. What strikes you about these results? I don't know what that one was about. And then someone was working out the system. What strikes you about those results? Not the last one. Anything? Yeah, in this small group, we've got quite a diversity of value. From 0 to, I think 2,000 is the highest I saw there. So that's quite a diversity. Now I'll just close this off. I trust you guys, but eventually if you leave them open for long enough, someone puts a swear word up there because it's funny. Of course that happens with undergraduates, not with postgraduates, never. So what we just did then, why can't I get that back? Here we go. So before we were talking about cost-benefit analysis, and we're working with dollar figures there, but sometimes there's no established market for something. That we can't work out what the costs and the benefits are, and we might have to ask people how willing they would be to pay. It's one of the ways of doing what we call a contingent valuation method. And so this was actually done with a couple of classes of students in Indonesia, and I guess I want you to think as a researcher as we go through this example. So straight away somebody said, well, even with our class, there was quite a diversity there. So how are we going to work with that? We've gotten some sort of data back from people, but it's very diverse. So what does that mean? Straight away, thinking about your statistics, you would know that that says something about the sample size that you might have to work with if we're talking about something that might have quite a large diversity, quite a large variation in terms of its accuracy. So these figures are in ringgits. Is anyone familiar with the exchange rate? What's a ringgit worth in Australian dollars? No one? Well, you can look it up afterwards, or just work in ringgits in your head right now. So, first of all, the first way is what we did. It's an open-ended contingent valuation method, where we just simply say, what would you be willing to pay? Okay, as you can see, we get a range of things from an emoticon through to $2,000. We actually have a combination of qualitative and quantitative that we're working with there, and a diversity. And so that's a real issue in terms of then using that data to make a decision. So what sort of things do you think you could do to try and focus the way people answer? So, for example, we had someone there drawing on knowledge of a better place to go and see orangutans. I guess one thing that you could do is refine the question very carefully, like with any research. Refine the question carefully and say, assuming that this is the only place to see orangutans, or assuming that it's your only opportunity to see orangutans, would you go, how much would you spend to go to this place? What else could you do, you think, to try and refine the way that this concept is operationalised to make it a bit more robust? One easy way that I could have done would have been to make the poll live so that as people were posting, you could see what other people were valuing it at. You could argue that that's a little bit biased, but that would affect the bid that future people put in if you saw how other people were valuing it. If you wanted a better research method, and you should, around that, you could use this second approach to CVM, which is called iterative bidding. So in iterative bidding, you start out with a broad framework, and then you try and narrow people down. So you're sort of guiding people. So instead of having this open slather, someone could say $5 million and someone could say 0. First of all, you're saying you're getting them to narrow it down between that yes and that no. So then you would get to group people into particular categories in terms of what they're willing to bid for this experience. So you can see there, if you're not willing to pay 20 ringgits to see the orangutan in the wild in this next year, would you be willing to pay 10? No. Would you be willing to pay 5? And then, particularly if it's not anonymous, you might want to stop there so that you give people the space, because there will be people that say not interested in orangutans. You give people the space to stop there. And similarly with the yes, you can work up there, and then you might have an upper value that you're willing to stop at and say this category of people is willing to pay, you know, in this case, 200 ringgits. Obviously, it's 200 plus. So by doing that, you help to control some of that variability in the method. So again, keep thinking about the issues that we talked about in terms of research design, in terms of trying to do statistics and analyse data. You need a way of collecting it that makes it as robust as possible. It operationalises it as accurately as possible. Okay, let's have a look at what these different classes said. So there were 3 classes of students, and they got everyone, there were 27 students in this first class, and the average value was 766 ringgits. However, the lowest value was 0 and the highest value was 20,000. So then we said, well, what if we eliminate the highest value? Is that triggering anything in your mind from earlier in semester? What are we doing there if we're saying we're going to chop out the highest value? We're going to calculate if some of these are outliers, okay? If they're not representative, if they're going to skew our average too much. So we're going to remove the outliers so that we get a more accurate average. So if we remove that 20,000, we end up with a value of 27 ringgits, which is quite different from 766, don't you think? Then, if you reduce the top 2, you come down to an average of 8. Now, presumably these students could just go up the road to see the orangutans, and so there's a range of variables that we're not aware of around how or why they're valuing this experience in this way. And I want to say very clearly, this is not going to be a representative sample of an entire nation state. But you can see there that this is a good way of presenting the variability in the data. Look what happens if we reduce the top 2. And then if you look at the bulk of the results, we've got 5 ringgits or less. Okay, class 2. Class 2, the average value was 19 ringgits from 24 response. The lowest was 0 the highest was priceless, which, I mean, says something to you about there's going to be a range of other confounding factors in here around environmental values and a whole perceptions of nature, etc. Obviously, you can't do much with priceless. It's a qualitative variable. I guess theoretically, if you had a maximum, if you weren't using the open method, you could convert priceless to your top category. So you can see there that using iterative bidding gives you a way of converting some of the qualitative answers into the highest or the lowest categories. So again, average if high value is eliminated is 15 ringgits. And again, well, only a third this time, 8 out of 24 indicated 5 ringgits or less. Class 3, average value of 37 from 26 responses. Lowest 0, highest 200. And then if we get rid of the highest value, we have an average of 23. 14 out of 26 indicated 5 ringgits or less. That should say or, typo. So you can see there that if you repeat this experiment, what might be starting to happen? What does this remind you of? That you need to have an extra coffee before 8 o'clock lectures? Sorry? I couldn't quite hear you. Mode. Okay, so the mode between what?
The people that answer that question, how much you willing to pay.
Yep. So you could, we might be starting to get, so you could look at the mode, but also some of the other things I was thinking might trigger for you as well is that you might be getting some sort of convergence either through the mode or in terms of averages as we increase this sample size. Some of the other things that should be going through your mind is these 3 classes are treated as 3 different replications of this experiment, 3 different samples, if you like. So if we wanted to compare those 3 different samples and work out if there is some sort of convergence happening, what might we be able to do? In this course, as soon as I say 3 groups and perform some statistics on those 3 groups, what statistical method jumps into your mind? Still got a few weeks to remember this. But yeah, I think someone said add over there. Okay? So, yeah. So you could check, is the difference, the means between these groups significant or not? If you're comparing 2 of them, you could do a t-test. If you're comparing 3 of them, you'll need to do ANOVA. This is just, I'm not saying that we will do that. I'm just trying to say to you again and again, these are ways where you can peg the tasks that we went through in the first 4 pracs into actually applying it to research. So we might be starting to get convergence on a value, and if we took the average across all of those 3 groups, we come up with 25 ringgits. That doesn't seem like much. You might say, if you're a big supporter of orangutans, you might say, well, these, they should be willing to spend much more. It's being undervalued. But the way that contingent valuation would work is that you would then multiply that by the population of, you could either do the whole of the nation state or just one region in the nation state, and you actually start to come up with a very, very significant value for that resource. If you say that that's the average value that everybody in that place puts on orangutans, then you come up with a value that's huge. What do you think are some of the weaknesses there of presenting that to decision makers? What are they going to say to you if you were the researcher that carried this out and then you went to them and said, we have to protect this forest, look how much this species is worth to the country or to Borneo? What are they going to say to you? Because these experiments have been done all around the world, and it comes out consistently that the value on nature, on natural resources that have no market, when we do these methods, they outweigh most development projects. They did it in Alaska on should we develop the oil in Alaska or protect the caribou. So how much are the caribou worth? And they did a contingent valuation method. Then they looked at the oil. They were able to do a standard cost-benefit analysis on developing the oil. And as usual, the natural resource, well, as usual, almost always, the public will value that natural resource higher than the development. So why then don't you see stronger use of contingent valuation method?
I think there is a big difference between what people say and what people do.
Yeah.
I think that would be one of the reasons why this is not completely useful.
Yeah. Yeah, so if we said to the class, how much you're willing to pay, now take that money out and put it on the desk in front of you. And we might not have anywhere near as much there. Or show us your bank balance and show us that you can actually afford that. And so often people have the best, their heart's in the right place, but for whatever reason, they don't or they can't or they don't get around to putting that money out there. But that's basically what it boils down to, is decision makers don't really don't trust some of these methods. There are ways to make them more robust. So you could, so they've used some of these methods to set entry fees for national parks. So how much would you be willing to pay to come into this national park? I went to one in Costa Rica. I think it cost $27 US. They had to do that because it was near a city and huge numbers of tourists were coming in and it was destroying the national, the natural values of the park. So they worked out, well, how many people, what's the carrying capacity of this national park? And therefore, they did a willingness to pay and they set a price to try and bring the numbers down to that carrying capacity. So then they were then able to gather data on that to see if it was the real willingness to pay or not. So there are ways to sort of use this as perhaps a way to get a ballpark figure and then actually put some sort of experiment in place to then ground truth that. But it's this ongoing issue of how do we put a dollar figure or way of measuring something that doesn't have a market or it's not got a simple quantitative measure. It's really what a lot of the career of researchers is about. How do we measure things in creative and accurate ways? Okay. So basically, that's where I want to finish today. Is that this is, I think, going to be one of the greatest challenges for practitioners into the future. In the break, we were talking further about ecosystem services and putting a value on natural resources that society depends on, and we get that for free. And more as we reach capacities around the world, we're having to make good decisions that think about, well, what is the effect on these resources that we're getting for free? Similarly, if you're a planner, what are the effects on social capital, social resources, or particular infrastructure within the city that we might get for free? So in Brisbane, you could do something to look at, well, what's the value of the river in Brisbane? And you might have to, in part, do a contingent valuation method and feed that into your research. Okay, so we're going to finish up there today. Some of you will have seen this before, but it's an interesting approach. In this course, we've just talked about cost-benefit analysis and multi-criteria analysis. Obviously, in cost-benefit analysis, you need everything in dollar figures, whereas in multi-criteria analysis, you're working with different units. These other ones in the middle here, well, they're sort of tools that sit in the middle there. We don't cover them in this course, but you can research them online if you want to look at cost utility analysis and cost effectiveness analysis. And if you're super interested, come and talk to me and I'll dig out some resources for you on that. But you won't be examined on those two middle tools there. I just think that that's useful framework to think about what sort of data is available to measure, and therefore what sort of tool can we feed that, collect that data and feed it in to make decisions. Okay, next week we're going to talk about a couple of other tools, importance performance analysis and benchmarking analysis. We're going to draw on some research that was done in planning for that, but all of this is very transferable across into other types of decision making. Importance performance analysis is, well, it is what it sounds like. You're trying to work out how important and compare the importance and the performance of particular public services or public investments. And benchmarking is where you're trying to compare what's happening on a project that you're working with other similar projects. Okay, we'll talk more about that next week. Great to see your mostly smiling faces again, and see you next week.